So for our next example, you can see that I'm giving you the graph of the function, but I actually haven't told you what that function is. So for this one, we're not going to be as precise as just a closer estimate using that curve. So the direction says find the lower and upper estimate for the area under the curve from 0 to 6 using 6 rectangles. So again, I need to calculate what that delta x is going to be. So I start with the upper limit minus the lower limit divided by 6. So this time, our width for each rectangle is going to be 1, which makes that nice and easy. Now, if I'm doing the lower and the upper estimate, I don't need the midpoint values. I just need the right-handed and the left-handed. So I'm going to take that rectangle and I'm going to kind of start breaking it up. If I need to break this up into 6 rectangles, I see 1, 2, 3, 4, 5, and 6. All right, and I'm going to use my x sub 0 position, x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, and x sub 6 positions. So I'm going to just start by doing the left-handed, breaking them up into 6 positions and seeing what that does for me. So what I'm looking here is I'm looking for what does x sub 0 gives me, because that's my left position. Now, since I don't have an actual function to plug this into, what I use is the curve itself. So I take that first curve and how high does it reach? So I'm only looking at an estimate there. So I'm saying that it's going to reach approximately 3 times the width of that rectangle, which we've already calculated our delta x to be 1. So there is our first rectangle using a left-handed endpoint. I'm going to add that to f of x sub 1 times delta x plus f of x sub 2 times delta x plus f of x sub 3 times delta x plus f of x sub 4 times delta x plus f of x sub 5 times delta x. Now, as I mentioned in the previous video, you're going to see that I'm not going to go all the way to x sub 6 because I'm using left-handed endpoints. So that already gives me 1, 2, 3, 4, 5, 6 rectangles. Since my delta x for each one of these are going to be the same, I can also kick that to the outside and just simply do f of x sub 0 plus f of x sub 1 plus f of x sub 2 plus f of x sub 3 plus f of x sub 4 plus f of x sub 5 and multiply all of that at one time times your delta x. So in this case, I'm looking at that left rectangle and I'm seeing that it's going to 3. When I get to x sub 1, I'm seeing that it's going to reach up to 4. And these are approximate, so we might not all have exactly the same values here. It's how we're visualizing it on the graph. When I get to f of x sub 2, I'm going to estimate that that is not quite at a quarter of the way, so I'm going to say that that's about 4.2. F of x sub 3, I'm going to say reaches about 4.6. Then I'm going to estimate that f of x sub 4 reaches at 5, and x sub 5 reaches at about 5.25. Then I'll multiply that all by my delta x, which is 1. So a quick calculation of my left-handed rectangles gives me 3 plus 4 plus 4.2 plus 4.6 plus 5 plus 5.25 gives me an estimate of 26.05. Since these are all going to reach underneath the curve, this is going to be my underestimate. And that's going to be square units because this is still area. Now, for my overestimate, that's going to be right-handed endpoints. So instead of this first rectangle starting at x sub 0, my first rectangle isn't going to start till x sub 1. So you can see right now that very first rectangle is already higher than that curve. So these rectangles are all going to be higher than the curve. Get all the way, and I'm going to include x sub 6 this time. So when I'm calculating this, I'm not going to start at x sub 0. I'm going to start at x sub 1 plus x sub 2, x sub 3, x sub 4, x sub 5, and x sub 6, all times my delta x. So these calculations I can kind of steal from up here because I already have x sub 1 through x sub 5. So I'm going to skip out on this x sub 0 term. I'm going to use 4 plus 4.2 plus 4.6 plus 5 plus 5.25, but I need one more. I need how far does 6 go? So I'm going to estimate 6 is going all the way to about 5.4 is my estimate, times my delta x, which is 1. So calculate this again. And I get that my overestimate is 28.45 square units. That's my overestimate. And that's going to take my area and bring it somewhere between 26.05 and 28.45 square units.